All right, everyone. Next up is our workshop. And this one is focused on accelerating AI on mobile devices with VidRow from Qualcomm. Welcome, Vid.
Hi, Sam. Excited to be here. Thank you.
Excited to have you delivering this workshop. Take it away.
Thank you very much. Good afternoon, everyone. And I'll just quickly share my screen. Give me 1 second. Are you able to see my screen?
Yes.
Awesome. Okay. So good afternoon, everyone. And in the past few years, what we have seen is AI has revolutionized various aspects of the smartphone experience, producing DSLR quality images with thin and sleek form factor. It has also changed how we interact with the device itself. Whether we are recording a video or adding our favorite effect on Snapchat, using our favorite filter, or getting or waking up the phone with a keyword to get the latest weather update, we are using on-device AI. What we have seen with respect to AI on mobile so far is just the tip of the iceberg. Although it's a significant amount of AI today, we believe it's still the tip of the iceberg. A huge transformation is happening as we speak, and the best is yet to come. So I'm very excited to take you through how this power of on-device AI can be harnessed to build compelling experiences. Okay, so here are some key topics that we'll cover. I'll start with the trends that are driving on-device AI. We'll look at a range of use cases and examples that make use of it today, followed by a couple of specific examples which give you a flavor of how deeply AI, specifically deep learning, is being used to improve user experience. We'll then look at what are the requirements and challenges associated with enabling these type of use cases. In a way, with the first three, we are defining the problem domain. Then we will transition to the solution domain on how Qualcomm is addressing these challenges through a combination of hardware architecture, in terms of accelerators, a flexible AI software suite, and a focused ecosystem strategy to accelerate deployment of AI-based features in this fast-paced industry. You know how fast this industry is. I mean, every year there's a new premium tier smartphone, and throughout the year there are a bunch of phones at different price points based on different chips. So from a product perspective, it's extremely challenging for the entire ecosystem to keep up. There's a lot of information to cover, and I'll pace this in a way where we'll cover the material in about 45 to 50 minutes, leaving the remaining time for Q&A. So let's look at an important trend here. I would like to focus your attention to the chart on the right, which shows an exponential growth in shipments of phones with some form of AI acceleration. Right? In 2016, it was relatively a small volume of premium tier devices, and as we went into 2020, and then as we are going into 2021, we are seeing a huge number of shipments of these kinds of devices. Why do we see this? There has been a rapid deployment of AI-based imaging, machine vision, voice recognition, speech processing, always-on sensing, and other use cases on mobile. Now let's take a look in more detail about what is driving this trend, right? For example, there are two key things. The first one I would say is traditionally what was done in the cloud. For example, if it is, when you wake up a device and ask for something on the device, the processing, or if, some of the complex imaging effects that were done in the cloud are slowly moving on device. The motivations are, security. First, you can, whatever you do on device, probably, more private and sort of also enhances security. It's always available, independent of network conditions. the cost in terms of whoever is operating the cloud, whoever is providing the service, the cost of operation comes down, and the latency, which impacts user experience, is also very favorable. Then the second trend that we see is the one that's above, which is if you go back about 3 to 4 years ago, a number of these, for example, imaging, if you're talking about applying a bokeh effect, or video processing, or audio, or sensors, these were all done using classic hand-coded algorithms. It was either CV, computer vision based for vision, or signal processing based for audio and other domains. Now we see a lot of them, a major part of them are becoming more and more AI based. So what that means is that is asking for more power optimized and high performance implementations, which in turn is driving the amount of acceleration that's going on a device and the shipments of phones and chips with AI accelerators. Now, this slide shows key use case categories that leverage AI on device. These span, for example, the biggest category, which is image quality and creative camera, to audio, natural language processing, gaming, sensors, video, and also applications, the over-the-top applications that are available from the Google Play Store, like Snapchat, TikTok, and others. Now, if you look at the camera, this is where we see a lot of traction, and smartphone users are very demanding with respect to image quality. And this has driven improvements in the past few years to the extent that we are often caught up with having to think twice or even thrice before deciding to carry a DSLR when we travel. There is a race to provide absolute best image quality by overcoming limitations posed by a relatively, much smaller image sensor, significantly smaller optics compared to an SLR camera, using computational photography, which heavily relies on deep learning algorithms today. This is reflected in the DxO mark score improvements from generation to generation. These image quality software algorithms are combined with the hardware processing that's available on the ISP, the image signal processor that we have always had. So we are kind of putting a lot more capability into the ISP as well, while being fully aware that there is a lot of AI post-processing also happening. So together, what we intend to provide is the best image and video quality via the native camera application. The native camera application is the OEM application that comes as a part of the phone. For example, if you're taking if you buy a Samsung phone, then what is a part of the Samsung camera app? So there are a bunch of algorithms that make use of AI there. For example, low light imaging, HDR, denoise, bokeh, video super resolution, image and video effects, such as face beautification, segmentation, and things like that. Then there are also, these are the native applications. This is based on native camera. In addition to this, what the camera is transforming itself into is more of a creative experience, with applications like Snapchat and TikTok, with the social dimension coming in. They're making it more creative with, where you can add image enhancements, creative augmented reality effects, and lenses that again use machine learning models for segmentation, skeletal tracking, and other features. Last but not the least, AI is used to make device unlock feature more secure and accurate. I mean, this is with a combination of, say, liveness detection. We're also talking about skin detection, for example, to making sure that it's human skin versus any other artificial kind of material. The other major area besides camera is audio. Audio-based, AI-based noise suppression algorithms for speech quality enhancement, keyword detection for voice UI, and sound context detection. What that means is, kind of monitoring to find out where, what the ambient conditions are For example, if you move from, if you're walking towards a subway station and you get on the train platform, right, sensing that it's a very noisy environment and, increasing the ring volume. Or at home, when you hear the glass shatter, somebody breaks into someone's home, then being able to send an alert. So enabling a new class of always on kind of use cases. Then NLP is another area where NLP, you could look at NLP today as where camera was a few years ago. It's still in its infancy, and it's supplementing audio and other use cases with such as a low latency language translation and automatic speech recognition. Then, of course, there are other video AI upscaling, video summarization kind of use cases where you get a summary of what the video is, or you have just extracts of those moments which were very interesting in a long video, and sensors always on analytics. So who are the contributors to these use cases, right? There are many of these use cases are coming from what we call ISVs, the independent software vendors, who work closely with the OEMs, such as, you are familiar with the Oppo, Vivo, Xiaomi, Samsung, a bunch of other companies. These ISVs provide work closely with the OEMs to provide these differentiated algorithms. OEMs themselves are developing in-house algorithms. So it's a combination of the ISV and the OEMs that are trying to bring out the best possible experience on the smartphone. Then this comes pre-packaged when you buy the phone. Above that, when you install your apps from the App Store, for example, Snapchat or TikTok or whatever that is, those applications also use AI in them. So these are the three major categories of use case contributors. And today, what we have enabled is more than 100 use cases just through our ISV partnerships, ISV and app vendor partnerships. So when we look at these 100 plus use cases in the remainder of the presentation, I would be referring to something called embedded. Embedded would be pretty much the ISV use cases which come by default. The OTT or app vendor would be something that is downloaded after the device is purchased. Then among the embedded use cases, there are OEM use cases and the ISV use cases that we just discussed. Then there are also OS, use cases coming from Android, from Google, right? So what we can expect going forward is just this whole trend to go on increasing, resulting in more and more use of on-device AI. Now, the previous slide illustrated the categories and the contributors for the use cases. Camera is arguably the #1 smartphone feature that users consistently look for improvements from generation to generation. Here we'll see what drives the need for AI horsepower, taking camera as an example, right? This is more of a holistic view of what is happening on the camera land. So if you look at the number of cameras that are used in the smartphone, that is increasing. Now you can find 4 cameras, wide, ultra wide, telephoto and super telephoto, right? And then you have pixels coming from 4 cameras. So in some cases using multiple cameras, in some cases using single cameras. Then the resolution of each of these cameras is also going up, upwards of 100 megapixel in some cases. Then what that means is per frame, per camera, you are getting a lot more pixels. Then the users, as they are becoming more and more demanding, they want to get that DSLR kind of experience. So what are OEMs and ISVs doing? They are trying to capture raw data, raw format from the sensor, and they are trying to process this raw format, which means the individual pixel, the amount of data per pixel is also increasing. And then in order to provide that quality, the neural networks themselves are becoming more and more complex. So all this is increasing the compute complexity that is required for use cases to run. Then there are KPIs, which is, what does the user expect from generation to generation? In fact, users are unforgiving when it comes to how quickly they want to see the pictures, although there is so much complexity going into it. So they want the latency to either stay the same or get better. And then they want more pictures per camera charge, or much longer videos per camera charge. So the power requirements are becoming more and more stringent. So what that means is we need to have power efficient AI processing. Then there is use case concurrency. So you have multiple use cases now. For example, if you're doing camcorder, you want to reduce you're recording a video, you want to reduce the wind noise that is coming, which is more of an audio kind of thing, while you want to apply a bokeh effect on the subject, so which is more of a camera feature. So there is a lot of concurrencies that are coming. Another feature from an AI perspective, right? The networks themselves, the topology of these networks, and the precision of data. For example, whether you use int8 or int16 to represent the weights, that makes a big difference, weights and activations. So we are seeing more and more increased leverage of higher precision for neural networks that impact image quality. So what is the net effect? And how are we keeping up with this trend? We are actually staying ahead of the curve and putting a lot of AI processing, just so that these new innovations are not starved and they make use of these on-device AI. And you can see right from our past 3 to 4 generations, the amount of AI that we have put on device is exponentially increasing. We announced Snapdragon 888 last December, and this is going to be our chip for 2021, and it has 26 stops of performance, or power efficient performance to be more precise. Now let's look at one camera use case, right? I mean, what we looked at previously was camera holistically. Now let's look at one flow, just to give a flavor of how much complexity is involved. This use case is called portrait relighting, which is, basically you take a picture, you apply a bokeh effect, and then some relighting to make it look like whether it's, whether it's candlelit or whether you are in a studio with good lighting effect, right? This is a very common kind of a use case. So what used to happen before? A few years before, if you see, there are several steps involved. For example, the data that's coming from the sensors in a certain format, it needs to go through remosaic, demosaic. These are steps that make the raw data that's coming from the sensor compatible with the upstream algorithms that work on it. For example, noise reduction, or HDR, which is high dynamic range, which means kind of giving you an accurate representation of the image while adapting to the huge change in the brightness levels, and then applying, say, a super resolution effect on top of that, which means you are captured the image at a low resolution. Now you're using AI to intelligently predict images to upscale it to a higher resolution. Then you apply a bokeh effect, which is you segment the foreground, the person, the subject, and apply a very nice background blur, similar to what you would get on an SLR with a very good lens. And then the relighting effect, right? So for these steps in the past, there were some pieces that were based on hardware processing. For example, the remosaic, the demosaic were done in either sensor or ISP hardware. Then denoise, HDR, classic, were done again in a combination of hardware and some hand-coded algorithms. Super resolution, bokeh, and the relighting effect were again hand-coded CV algorithms before. What is happening now? So there are various flavors. Many still leveraging some of these, some of the hardware and the classic approaches, but there are ISVs and OEMs who are innovating on specific pieces. They have IPs on specific blocks, which are AI-based, which is pushing the envelope on accuracy and making and providing that uplift in image quality. So everything, or pretty much here, has an AI-based implementation, which means what was done in hardware and through hand-coded algorithms Now moving to AI, which is in turn increasing the amount of demand on the system in terms of the horsepower that's necessary. Now let's look at a different category of a use case in a different category, moving on from camera. This is a natural language processing example, where low latency language translation is one of the use cases we are focused on. What this use case does is enable people to overcome language barriers and communicate seamlessly using voice and video calls. It could even be in offline mode. For example, if you're traveling in a taxi and then you want to talk to the taxi driver in a different geography in English, and he understands in his own native language, right? So let's look at it from a voice call perspective. So if a user, say user one is speaking in a certain language, then the speech goes through analog to digital conversion. Then there are some AI-based algorithms for noise suppression. Even echo cancellation, there is exploration in terms of using AI. And then the cleaned up speech is it goes to an accelerator where we ideally want to process, where there are three algorithms: ASR, which is automatic speech recognition, which recognizes speech and converts speech to text. And then the converted text, for example, English speech converted to English text, passes through a neural machine translation piece, which understands this text, understands the semantics, the language, and translates it into the destination language, kind of maintaining the integrity of how the sentences are laid out. And then NMT, once that is translated, there's a text-to-speech engine in the destination language that kicks in and translates, say, from Mandarin text to Mandarin speech. And then this goes through the other components like the modem and the RF front end of the phone to the other user who hears user one's speech, which was originally spoken in English, in his native language, say Mandarin here, somebody in China listening to this. And he speaks in Chinese, and then that goes through the opposite flow and gets translated into English. And this happens seamlessly. The user too doesn't need to have any of the software or hardware, it doesn't need a special phone for this to be running. In fact, all this happens on user one's phone and he doesn't even know. So the idea is to actually make it very seamless. And as I said, this is almost like a research kind of use case. We are pushing the envelope on what's possible. So what are the requirements here? The requirements for neural networks here are very different from what we saw on camera, which are classics, more of the CNN category, the segmentation, the object detection, tracking kind of neural networks. Here, the neural networks are more LSTM, RNN, GLU, and the innovation is happening a lot on transformer-based neural networks. Transformer, with its attention mechanism, has truly revolutionized the NLP space. There are many architectures that are transformer-based that are gaining traction, such as BERT. And this comes up with different kinds of ops, different kinds of topology. Then the constraint here is low latency, and then very good power consumption, performance, and concurrency, right? And with power consumption requirements also comes thermal requirements, which means even upon using this for a long time, the phone should not heat up. So that's the second category of use case that you saw. This is the third category, which is ultra low power, always on, which means the requirements here are very different. Here, the device is always listening to, for example, if you say, Alexa, what is the weather right now, or something like that, a voice, a wake up kind of thing. Or you want to listen to the sound context, like I mentioned previously, and find out what's happening around and make adjustments to the phone. So what happens in this flow is the sound coming from the mic, the voice or otherwise, right, gets cleaned up and gets passed into these different blocks, depending on what is the context. For example, if it's biometrics, if it is, if you're actually authenticating the speaker, or if it's voice, voice wake up, voice activation, or ultrasonic sensing, or sound context. So sound context is what we discussed earlier. And depending on what that is, it gets passed to the bigger, it wakes up the rest of the system and passes it to the other compute blocks to process. The low power, the ultra low power system actually runs, we have a specific hardware setup to be able to run that within the audio DSP kind of subsystem. And we use special memory, the tightly coupled memory. We turn off the DDR and the requirements that comes with it, with very low footprint neural networks, very low resource utilization. So this brings a different dimension to the constraints we have. Then, so you saw different categories of neural networks. Now let's look at what are the set of challenges that come with these neural networks, right? So let's skip the easy part, which is training. I know I can imagine the look when I say, the training is the easy part. I mean, I'm just kidding, but you'll see that inference is extremely challenging as well. So when you have the trained model, that needs to be, to get the best power performance, it needs to be quantized, compressed, and then you choose, there has to be a choice of the inference framework made with different, keeping different priorities in mind. For example, what are the layers supported? What are your network requirements? What is the level of abstraction? Whether you want something at a network level or you want at a, at a graph level. You want to program, you want to set up the graph and run it. Or what kind of operation do you need? Do you want to target one specific family of chips, or you want to target everything, all Android-based smartphones, or all smartphones, right? And then the ease of use. How do you want it to be? Do you want to be up and running? You want to prototype very fast and deploy in 6 months, or you have the bandwidth to take this up as a long-term project and do it in 1 year, right? And then how do you scale it to different series of chips, which power phones at different price points across different geographies? And these chips, we try to keep the architecture and the programming interfaces as homogeneous as possible, but but there will be architectural differences, given the cost and the other trade-offs that need to be made. At a high level, this is a 30,000-foot view of our accelerators. There is a CPU. CPU is present by default. GPU is also present, which is the next option as an accelerator. And then the hexagon processor. This actually refers to a family of processors that are on chip, which refers to a fused vector matrix accelerator that we have, scalar, vector, and matrix accelerator that we have, which is high performance, and also a bunch of low power, always on type of accelerators as well, which all belong to the hexagon family. Then what are some of the other challenges here? The training frameworks as well as the inference frameworks are rapidly evolving. So it's always running on the treadmill to keep up with them. New neural network architectures and new operators, given the rapid amount of research that is happening in the space. Quantization and compression. Now you have a floating point, you have trained a network, you have great accuracy. When you bring it on device, you have to quantize it. And then when you quantize, you lose accuracy sometimes. And do we, can some techniques that are already, the most recent research-based techniques be leveraged to regain that accuracy? Power performance optimization. Then model security. How do you secure model? And I mean, in some, there are different, the view differs depending on who you talk to. Some want higher level of security compared to the others. Then how do you scale this across chips, right? And then always on design. How do you design it in such a way that, for low power and memory footprint? Network partitioning. How do you partition your network across these accelerators? And new and custom layers to be able to give flexibility to development. Then those were the challenges in general that you saw that applies to all categories, OEMs, ISVs, and app vendors. But app vendors who are, who are a part of the, which are loaded after the phone is purchased have other additional challenges as well. They are adopting deep learning in a big way. They want to have one design, one set of algorithms that they can scale easily across tiers. They want to go across OEMs and operating system versions. And they want to leverage, they want to keep the memory footprint as small as possible. They want to increase developer productivity because their focus is more of differentiating in the application domain rather than spending a whole lot of silicon specific effort. So I won't get into all the details here in the interest of time. Now we defined the problem domain. We spoke about the different kinds of use cases, the challenges and the constraints that come with them. Now let's quickly take a look at the solution domain. How is Qualcomm addressing this challenge? From an architectural perspective, from the hardware architectural perspective, we have a heterogeneous model, which means we want to channel the workload to the best possible core and the core that has the best power performance profile. And there is no other choice, as we see, because because of the spectrum of these use cases and the contending priorities. Then, with this heterogeneous architecture, we have come up with API and SDK options that are flexible to address a wide gamut of customers, if I may say, like all the way from OEMs to ISVs to app vendors to individual developers who want to use these APIs. And then we want to simplify other pain points such as quantization. I just mentioned quantization. There are many others that we saw earlier. So ultimately, we want to provide flexibility and efficiency. One secret ingredient that I haven't highlighted here that we will be covering in more detail is the ecosystem approach that has been able to bring a lot of efficiency into deploying these use cases. Then, touching upon the heterogeneous architecture, our AI engines at a very high level, again, there are a lot of details, can be divided into two categories, the CPU and GPU, which are capable of FP16, floating point 16, and FP32 inference. We are improving efficiency on the CPU and GPU as well. But you get a quantum leap in performance and power efficiency when you look at, when you move to this hexagon family of processors, which is where we accelerate the tensors, the vectors, and even the scalars. So to be able to leverage that, one needs to quantize the network either to int8 or int16. 3 years ago, this was a big challenge. We had several networks not falling into this category, but through research and our work on quantization, we have increased the coverage in terms of the networks that can be quantized, and we have improved the quantization flow. So if you take int8 and int16 networks, more than 90 or even 95% of the networks that we have today, that we deal with today, fall into this category. And then in terms of, this is just indicative of the performance that we have had in the previous generation. CPU, if it provides 1x, right? This is the reference. If you go to the tensor accelerator, you get about 21x. This can vary with chipset, but given one chip, about 21 times the performance. Now, if you actually, this tensor accelerator and vector extensions are both support quantized inference. In fact, you can deploy or partition your network to use both of them. Now you can imagine the amount of performance and power uplift that you get when you quantize. Then in terms of API options, we have the Qualcomm Neural Processing SDK, commonly known as Snappy. So this is deployed on 500 plus million mobile phones today. And this is a Qualcomm API. In fact, this was the first on-device AI acceleration API in mobile. So the key advantage of this is because the development of this API happens in tandem with our hardware and chip development, it supports at any point our latest and greatest accelerators. The dev profile is varied. For example, you can start prototyping very fast on this. It's very easy to move your network from training to inference with the tooling that it has. And it can take you all the way from prototyping to deployment. So it's a very efficient framework from that perspective. And it's user extensible as well. For if you have new, it has a rich set of operators, but if you want additional operators, it supports that as well. So now we also, so this caters to a large portion of our customers, but there is a section of our customers that say, okay, we have our own proprietary inference framework, and we want direct access to your hardware, direct access, low-level access to your software, which is a graph-level access. So we have enabled that as well through our Qualcomm AI Engine Direct interface. And then an equivalent to that in the legacy domain is Hexagon. And then the only reason why I bring up is this is something that's already popular among developers and they know about it. Then there is, of course, we support the options from Google. We work closely with Google to enable TensorFlow Lite and Android NN API. That's very well known, so I will skip it for the time being. Now, just again, bringing the perspective back to the depth of, to the breadth of the AI use cases that we support. So we saw all these use cases on camera, the camera effects, authentication, object and scene understanding on video. So another key trend that we see today are all these the complex camera pipeline example that I spoke to you about, that I just mentioned, that is transitioning now to video. So just imagine the amount of processing and doing that at 30 FPS or 60 FPS. So that in itself is a huge undertaking. Then that is getting more complicated with creative effects, such as a super movie that we demonstrated. If you do, I mean, it's something that would be worth checking out if you search for it. We made it we showcased it in our last year's announcement, Snapdragon 888 announcement. Then there is NLP, which is shaping up in a big way, audio, voice biometrics, and all this that's coming up. And then security also is going to use more and more AI. So now I just want to give a perspective on the complexity, right? Let's look at all these combinations. We saw the different hardware engines, the accelerators. We saw all the chipset tiers on which a solution vendor would need to scale their solutions. There are different AI framework and API options. Now combine that with a number of use cases that one has to develop in a very constrained schedule for smartphones. Multiply that by the power, performance, and memory constraints. Now, with these use cases becoming more and more complex, now you have to manage power as well. You cannot exceed the power budget. So the complexity actually goes through the roof. Now, how do we simplify this, right? So we listened to these pain points from our ISVs and our app vendors and OEMs, and we shaped our ecosystem approach. So that is where our platform solution ecosystem comes in. And I'm a part of that team. I'm a product manager in that team taking care of the AI partnerships. So we have taken a two-pronged approach here, which is technical as well as marketing. So what we figured was, it's not, we can't just look at it from a technical perspective. We have to bring the product management marketing angle along with the technical angle to help our ecosystem partners make the best trade-offs, make the best decisions in bringing differentiated solutions. And we have seen a lot of success with this. What happens is on the technical side, we engage very early alongside OEMs that get access to our hardware. We provide hardware access and software access to our partners as well. Then we start architectural discussions with them in terms of, okay, what is your use case? What do you want? What do you want to accomplish with them? What are the KPIs you want to achieve? What are the frameworks? What is the, what are the constraints you're seeing? What is the amount of effort that you can use? And then we help them scale them to multiple chips and come up with an acceleration strategy. And then we have a dedicated engineering team that walks them through this process to be able to take our latest and greatest APIs and accelerate on the hardware blocks that our hardware development, software development teams have put together. Then we discuss about pre-integration, which means we get these solutions integrated so that by the time we launch this chip, which is much before the actual phone gets launched, these are available as demos to OEMs. So these ISPs, which are technology solution vendors to OEMs, they can go to these OEMs and say, we have an optimized solution on Qualcomm platform. Would you be interested in evaluating it? Or so it makes the whole process for the OEM as well as the ISP so much more seamless compared to what was happening, which was last minute huddle in the past. Then from a marketing perspective, we feature these solutions at launch events. There's a lot of PR, and we have a website, a portal on which OEMs usually come and look at which solution vendors have what kind of use cases. So it gives a lot of exposure to OEMs. So with this strategy, we have seen a lot of success. Now, taking a more broader view of what we are doing, right? Then the early validation, debug and functional validation of key aspects of the use cases that reduces time to market, helps the OEMs as well. The insights that we provide to our technology partners and app partners in terms of, okay, what is coming up in the roadmap? How do they partition their, how do they architect their networks or their acceleration strategy to keep to stay in tandem with how our hardware and software architecture is evolving, taking that through solution architecture and finally deployment. This is an even more broader view. I spoke to you about how we take use cases with our application vendors and ISVs. There is also an element of independent hardware vendors. These are sensor vendors and module vendors, camera module vendors. So our objective here is to optimize it end to end so that leads to successful deployments. You can read more. There's a link here to our platform solution ecosystem blog if you're interested. To summarize, AI is a very powerful tool that has revolutionized user experience through the years. To take advantage on mobile and to deploy the most power efficient performance solution, most differentiated solution, there is significant complexity. Our approach with the platform solution ecosystem team is to provide the most optimal approach for the solution vendors and partners. This is how we have evolved the whole thing so that we bring all these, we conquer the complexity and bring this in time for our OEMs to deploy. So this is our rich and growing ecosystem of partnerships. The three columns on the left, 1, 2, and 3, have the software vendors and partners with whom we collaborate. And most of these partners use AI in some shape or form. Some use to a greater extent, some are getting on board in terms of using, but the trend is only increasing. Our OEMs see tremendous value in it, and our partners as well. For us, we would love to see our hardware and software infrastructure being optimally utilized to deliver differentiated experiences. At the end of the day, we all aim to delight the smartphone user with every new generation of products. So, I know this is a lot of information. I went through very fast to allow time for Q&A, and it's about 12:45. And with that, I'll open up for Q&A.
That was a ton of information, Vid. Thanks so much for sharing it.
Happy to.
We do have an question in from the chat from Thomas, and he's asking about how federated learning plays into this. So with the rise of federated learning, how is Qualcomm thinking about training neural networks locally? Any thoughts on that?
Absolutely. I think that's a great question. So federated learning is a very important trend. In fact, given the current privacy, focus on privacy, it's becoming more and more important. As we go later into, right now, federated learning, is more in the is in early stages of development. So the way we are looking at it, we are adapting our neural network frameworks and our hardware to be able to take advantage of this. It's given that this is still in early development, there's very limited amount of information I can share. But what I can say is this: we are very focused on this, and going forward, you will hear a lot about it.
Awesome. Yeah, you use the terminology platform in the sense that that you use it often there at Qualcomm and in the mobile arena. We've been talking a lot about a different type of platform over the past couple of weeks here. And it begs a question for me: how do you see folks integrating the mobile specific parts of their AI development workflow into their broader kind of end-to-end training and deployment workflow? Is it kind of a manual step that happens in the training process, or are there some automation opportunities?
Absolutely, that's a great question, Sam. So here, if you look at it, right? I mean, it's kind of an oversimplification. So what we want to do is once someone trains their model, we want to make this transition from cloud to on device. A lot of companies used to do this on the cloud, used to deploy inference on the cloud even for mobile. As many of the mobile use cases now we see cloud is growing in its own right, but we also see um, several of these use cases transitioning on device. So to make it simpler, right, we have different API options, like I mentioned. One of the options, the neural processing engine, is the easiest one. So what we do there is once you train your network using TensorFlow or PyTorch, or if you have a proprietary training framework, as long as you can bring it, convert to ONNX format, once you have the training network, once you have the network, you could export that network, the train model, with fixed weights and biases, either in ONNX or one of these formats. Once you have that, we have the tooling in place to be able to convert that train model from this format to a format that is easy to deploy on Snapdragon. So it's just a command line kind of thing, a PC-based tool that you can run, and you get this format called the DLC, or deep learning container format, which our inference framework understands. And then that's it. And then the only important thing here is to make sure all the layers are supported. We always try to keep up with the latest versions of the training frameworks that are available. And then if there are any ops that need implementation, specific implementation, we have a mechanism for that as well.
And so maybe to dig into that a little bit further, some of the mobile specific processes that a user might want to do, like quantization and pruning.
Absolutely, yeah.
My sense from conversations is that those are often kind of handcrafted processes, as opposed to there's just a process that you run and you get a result out on the other side. At least when it comes to really trying to squeeze the most performance out relative to the size and energy consumption for a given model. Is that still the case, or is it more plug and play now?
That's a great question again. So, yeah, it was a pain point. Completely agree with you. Like 2 years ago, 3 years ago, it was mostly hand tuned. You needed to do all these different things. So what we did was we have very active research going on within Qualcomm on compression quantization, right? We published in CVPR 2019 something that was very well received in terms of quantization flow. Now we have a tool called AIMET, AI Model Efficiency Toolkit, which we open source, a part of which we open sourced, which actually brings several features For example, before this, networks like Inception v3 could easily be quantized, but when you go to MobileNet, the accuracy after quantization suffered. We brought a few techniques here called, cross-layer equalization, bias absorption, and several other things. Kind of the basic idea is to make these weights, bring these weights into a range, and even look at the activations and bring them to a range where you get very good accuracy. So we have been, whatever has come out of that, we have been putting into this toolkit. We have also made it a part of our Snappy, the neural processing engine flow. So it's in a way, it's available pre-integrated a command line option for neural processing engine. It's also available as a part of this AI model efficiency toolkit that you can plug into your training and development flow independently. What we are working on is to make to widen the gamut of networks that quantize well and go to lower bit widths like int6 from int16, int8 to int4. Also plug into quantization aware training flow with something called range learning. There are, when post-training quantization doesn't work, we have put a lot of emphasis on post-training quantization to reduce the pain in taking the network from training to inference. And a lot of, our ISPs, OEMs, and other partners have seen a lot of success with that. But for networks that don't fit into that, where quantization-aware training becomes a requirement, then this AI MET can be plugged into that to provide you a view of what would be the actual accuracy, to model the accuracy on hardware, and where you need to be, putting your fake quantization nodes and all that, and making that whole process much simpler to bring it on mobile. Last but not least, what I want to talk about is mixed precision support. We expect this to be coming as well, which is for example, a portion of the network running in int8, a portion of the network running in int16, so you get the best of both worlds in terms of accuracy as well as performance.
Awesome.
This is about the quantization, and we also have compression as a part of this tool as well.
Okay, great. Any additional questions from our audience? Thomas, did we answer your question regarding the federated learning? And Vid, related to federated learning, are you doing anything in the differential privacy arena? Has that come up?
Yeah, actually, on the federated learning topic, there's so much, there's a active research going on, and because that's a topic that's early, sort of constrained a little bit in terms of sharing the details. But it's all I can say is there's a lot of good work going on in that space.
Awesome. Yeah, for folks that are interested, I've done several interviews with folks on the Qualcomm research team, and we can drop a link into the chat to some of those, or you can just Google TWiML AI Qualcomm and you'll see some of them. A lot, if there's folks on that are interested in deep learning on graphs, there's a ton of interesting content on that in particular.
Yeah. So, you could look at the papers, and Sam, your interview with one of the interviews with Jeff Gelhar, and I believe I don't know if you have done an interview with Gillet as well, and a bunch of those very insightful interviews that talk about research. Absolutely.
Awesome. All right. Well, Vid, thank you so much.
Yeah, it was a pleasure, and great forum, and very interesting questions. We'll keep you posted with more and more interesting stuff as we go along.
Awesome. Looking forward to it.
All right. You have a great rest of your day, and thank you all for participating.
Thank you.